Hey everyone, welcome back to the channel Code with AKJ. Today is day 41 of solving Geeks problem of the day. So today's question is palindrome linked list. So the question says here, given a single linked list of integers, the task is to check if the given linked list is palindrome or not. Given example here, the linked list contains values 1 to 1, 1 to 1. So by observing this particular linked list, we can say that this is a palindrome linked list as values are present in the form of palindrome. So today we'll tackle a classic linked list problem, checking if a single linked list is a palindrome. This is a popular coding interview question and we'll go over two approaches, starting with the brute force solution and then moving towards the optimal approach. So if you're new here, make sure to subscribe for daily coding solutions and hit the notification bell for updates. So let's dive in with the brute force approach. So let's start with the brute force. The simplest way to check if a linked list is a palindrome or not is by using the extra space. Here, as you can see, the linked list 1 to 1, 1 to 1. The brute force approach here would be to store all these linked list integers in the form of array, and we'll reverse this particular array and check for palindrome. So the brute force approach is simple, and here the time complexity would be O of n as we are iterating over the linked list, and space complexity would be O of n as we are using external data structure array. So let's move on to the code of this brute force approach and let's move on to the optimal approach. So this is a code for the brute force approach, and here I've taken the vector of vals which will store all the node values in the form of vector, and I've taken a current node star value which will be initially at head pointer and it will iterate over this particular linked list, and while it becomes null pointer it will store all its data into our val vector and will move the current pointer to the next value parallelly. So after storing all the nodes in the vector, we'll check if the vector forms a palindrome or not by reversing it. We can use a reverse function here, which is present in C++ inbuilt functions, or else we can use a single for loop where we'll compare the first half values to the next half values. If we find any values not equal with each other, we'll return false, or else we'll return true at the end of the function. So let's compile and run this. So let's submit. As you can see, this problem got accepted successfully, but here the time complexity would be O of n and space complexity would be O of n. But here our expected time complexity is O of n, but space complexity is O of 1. So we need to find a way or approach where we try to reduce our space complexity and not use any kind of external data structure, as we have used vector of val in our brute force approach. So while this approach works, the extra space used for storing the values can be avoided, and let's move on to a more optimal solution that does not require any additional memory. So now let's solve this problem more efficiently by optimizing both time and space. The idea behind our optimal approach is to use a two-pointer technique where we can split the linked list into two halves and then reverse the second half. So once we reverse the second half, we can compare the first half with the reversed second half, and if both halves will match, then we can say that it is a palindrome and will return true that this particular singly linked list is a palindrome linked list. So let's break it down step by step. So what we'll do here is, first we'll find the middle of this linked list using two pointers, which is slow and fast. This method or approach is also used in finding the middle of a linked list, or we can also use this approach in finding whether the singly linked list contains a cycle or not. So first we'll use the slow and fast pointer technique to find the middle of the linked list. Next we'll reverse the second half of the list, and finally we'll compare the two halves for the check for equality. Let's dry run this approach and let's move on to the code later. So here, with the help of slow and fast pointer, here our mid value would be 1, and we need to reverse the second half of the part, which would be 1 2 1 and again 1 2 1. So this would be our second half and this would be our first half. We'll reset this first pointer to the first linked list head and second pointer to the second linked list head, and we'll compare each values by moving these pointers one step ahead. And if at any point data is being mismatched, then we can say that it does not form a palindrome. And if all the data matches, then we can say that it forms a palindrome. And finally, the linked list is a palindrome linked list. So here the time complexity would be O of n, as we are iterating over the linked list only once, and the space complexity would be O of 1, as we are not using any external data structure. So in this way, we have optimized our space complexity by converting it from O of n to O of 1. So this would be our optimal approach, and in this case, this forms a palindrome linked list. And let's take another case where it does not form a palindrome linked list, and later on we'll move on to the code. So let's take a linked list with values 1, 2, and 3. Here the midpoint would be 2. So we'll reverse the second part of it, which would be 3 and 2. So first part would be 1 and second part would be 3 and 2. As we compare these 2 pointers values, since they are not equal, we can say that it does not form a palindrome. And finally, we can say that it is not a palindrome linked list. So in this way, our optimal approach will help us find this particular linked list, whether it is a palindrome linked list or not, in our expected time complexity and space complexity. So let's move on to the code. So this is a code for the optimal approach. We have discussed through few examples, and here the code goes like this. Here the edge case or initial case would be our that head is null. We can say that empty linked list is a palindrome linked list, so we'll return true. So we'll take 2 pointers which would start from head, and we'll find the middle of the linked list using this for loop while fast is not equals to null. So this is a very well known approach to find the middle of the linked list. And after finding our middle of the linked list, we'll reverse the second part of it, and we'll reinitialize our fast pointer to our head, and slow pointer would be at the second half of the linked list. So we'll check while slow is not equals to null. If slow's data is not equals to fast data, we can say that the data is not matching and will return false from there. Or else we'll move slow and fast pointer one step at a time. After completing this while loop, we can say that every data from both halves of the linked list are matching and will return true from here. So reverse function goes like this. We'll take the help of 3 pointers and we'll change the links using these 3 pointers, and we'll reverse the particular linked list in the way of n time complexity. This function takes O of n time complexity, and running over this linked list will take O of n time complexity. So the overall time complexity would be O of n. And as we are not using any data structure to store any integer values, we can say that our space complexity is O of 1, which is our expected time complexity and space complexity. So let's compile and run this. So okay, so let's submit. As you can see, this problem got accepted successfully with our expected time complexity and space complexity. So in conclusion, we explored 2 methods for checking if a single linked list is a palindrome or not. So the brute force method uses a vector to store the list values, but it requires extra space. The optimal approach uses the slow and fast pointer technique to reverse the second half of the list and then compare the 2 halves, all while using the constant space. So if you found this video helpful, please like, share and comment below with any questions. Don't forget to subscribe for more coding content, and I'll see you in the next one. Thank you.